Let's start with integers. We create a simple variable. Let's say we create variable a and we'll assign any numeric value to this. It could be, let's say, 101. Now, an integer value in Python can take a number of any size. Now, since we already discussed, whenever there is scope for an integer overflow, Python automatically typecasts an integer to long and increases the precision. So we don't really need to bother about int and long. We can just go on typing a large number into any variable, and the entire process of typecasting it and allocating more memory happens internally. Now, the way I would execute this command, this being a Windows system, would be I would select or highlight the command and I would press Control and Enter. This would be different in the Mac or Linux system. In Mac, it would be Command Enter, and in Linux, probably it might be Control Enter, similar to Windows. I would leave this to you, just a reader, to figure it out. For Windows users, you can choose Control Enter to highlight and execute the command, or you can also type in the command into the console and execute it. Now, to check the type of the data or the data type, Python actually provides a command called type. So if I say type of A and if I execute this command with Control Enter, we can see that data type is int. This would have already been visible with the variable explorer also. So there's a variable name called A, the type is integer, the size is 1, and the value is 101. What we need to bother is probably the value, the name, and in some cases, the type. You can also do a lot of mathematical operations on the data. So let's say, like any other language, you would want to execute some mathematical operations like addition, subtraction. It's very straightforward and similar to what you have learned in the past. So I would say, let's say a is equal to a plus 6. And if I want to execute this, I can see the new value is now updated, 107. I can verify that with a print command. So let's type a print command as a print of a, and you can check the value here. So the value is 107. If you want to check the type of a, again, that would be int. Similarly, you'll have additional mathematical operations. Let's say something like a is equal to a minus 8, or let's say take a larger number, a minus 89. That gives a negative number. Oh, sorry, since this is a large number, let's say 890. Now we should definitely have a negative number. I can do a print of a, the value is minus 872. Type of a, it's still an integer number. Now, there are scenarios where a number is typecasted to another data type to avoid precision loss. So, for example, we would go ahead with a division operation. So, a is equal to 87 divided by 12. Now, the resultant number will actually be a decimal number. So to avoid, so had this been just an integer number and it was supposed to remain an integer number after the execution also, there would have been some sort of loss in the precision. So to avoid that, to avoid information loss and precision loss, Python would typecast it automatically to float. So if I execute this number, you can see that the data type changes, the value is 7.25 and the type is float. This would be the same if we had something like let's see, we again have a is equal to 101. Now a is integer, and I will say a is equal to a divided by 12. Now the assumption would be a is integer, like we see over here, and the resultant a after the execution also should be integer. But that won't be the case. So since we divide 101 by 12, we would actually typecast that to a float number. There you go. You can see the type has changed, float, and we have the new value stored over here. Now we've covered integers, we've kind of covered float, and the kind of arithmetic operations that's possible with integers are also possible with the same data type float. Probably all of them, which falls under the bottomless rule. Let's look into a very simple data type called Boolean. A Boolean is a data type which actually stores value of true and false. Now in Python, instead of using the values 1 and 0 for flag, you can actually use the value true or the value false inside a variable. Now, if you create a Boolean variable with a Boolean value, let's say flag is equal to bool, and we execute this command, by default we'll have the value false stored in it. In some cases, when you override the value, you can actually say flag is equal to true, and we'll have the new value coming up over here. And this data type remains bool. Boolean is actually a very handy data type in cases of conditional statement execution. So when an if clause or a while clause, you have to check a condition. Boolean variables, since they have the values only as true or false, becomes extremely handy to check and proceed. Next is another popular data type called strings. So character arrays or strings are the most popular way to store text variables. So I'll say A is equal to my name is XYZ. And if I store this and execute this, you can now see that the data type is str, which stands for string, and we have a string value over here. You can do some string related operations over here. Now, Python provides a rich set of set of functions associated with the string variable. So for example, let's say you wanted to reverse a string, you want to capitalize a string, you want to slice a string, or you would like to, let's say, uh, check for some substring positions. All of those functions are already made in string. We can actually, we'll look into this later. I'll just show you an example. Now, since this is spider, you'll actually get autocomplete and function lookup also. So since A is a string, let's say I execute this and A is a string, and I would say A dot, the kind of functions associated with the string comes up. So we have an exhaustive list of handy functions for string operations over here. So probably anything you would have already used with strings in something like Excel or R or something like Java or C++, all of them have been neatly added into this exhaustive library. So let's say had this value been my name is XYZ with a small m, and we need to capitalize this letter, so we can use something like a dot and say capitalize. We call this function. We can see the value will have been updated. Oh, my apologies. Let's say a dot is title, or let's say if we create title. Yes, title. So this would actually capitalize the first letter of a sentence. As we see over here, my name is Khan. Sorry, my name is XYZ. My bad. Alright. And then we have a list of other commands like a.strip, split lines, start split. So all of these functions we'll be using in a while we do data engineering and data manipulation. So all of these functions actually come in handy. So is alphanumeric, is alpha, is decimal, is digit. These are functions which are used very frequently, and then we do slicing and dicing across strings. All these functions are very handy while we do string-related operations and data manipulation in the upcoming sessions. Another way to concatenate a string would be, I would say, let's say you have a new string called B, and you want to concatenate A with the new variable or the new value. I would say just a random sentence, please ignore the grammatical syntaxes. Yes, so you can see that the new value is now, my name is XYZ, without a space, and I am cool. This is how you can concatenate two different strings. If you want to make it more neater, I'll just say concatenate a space and then this one and then go on as long as you want, and this gets a little neater. So that's strings. We've just seen a sneak peek into the data type. There are several other possibilities and functions that we can play around with the string data type. So we've covered four important and basic data types. We've covered integers. Sorry, let's start again. We've covered integers. We've covered float. We've covered string, and we've covered boolean. Let's look into a couple of more advanced data types offered by Python. We now need to look into something called list tuple, set, and dictionary. Now, out of all these four, we'll be very frequently using the data type list. So like we already learned, list is a collection of homogeneous or heterogeneous objects with Python in any order. So let's say we have four different values, let's say numeric values 1, 2, 3, 4, and then we want to sort them into a list. So I'll say list 1 is equal to, now this is a syntax to create a list. We'll actually put the values inside a square bracket. I'll say add a few numeric values like 1, 2, 3, 4, and 5. So these are homogeneous values. If I check the list, I can see that the name list1 comes with the type list. It has a size of 5 elements, and these are the values. I can access each individual element with the appropriate index. So as a list of 1, and I'll take the 0th element. Now indexing in Python starts with 0. So let's say if I say list 1, 0 index, I'll actually get the value 1. As you see over here, we have the value 1. I can actually make something like something more random. I'll say a list of 4. I'll get the 5th value in the index, that is 5. I can actually take a start point and an end point. I'll say everything from 2 to 4. And I'll say that whatever starts at 2, which is 0, 1, 2, the third one, up to the fourth one. And this goes on. We have additional handy ways to navigate through a list. So let's say everything from the second one onwards, from the second index onwards. So I'll get 3, 4, 5. And we have a couple of additional ways to handle them. Now, lists can also be added with new elements. So let's say I have list 2 is equal to 3, 4, 5, 6, 80. And I execute that, so I have list 2. And if I want to create a new list, list 3, which is a combination of list 1 and list 2, that is possible by just this concatenation statement. I'll say list 1 plus list 2. And if I execute this command, I can see the list 3 is a combination of list 1 and list 2 with the size 10. List also provides you additional handy commands. So let's say if I want to check something whether it exists inside a list, or I want to check the length of a list, you can just say list3 and just say dot. Spider provides you the list of commands that are already available. So let's say I'll say list append, and I'll say append a new value called 98, and I'll check the value over here. So the value is now updated. So I can just say a list print list 3. You can see that the value has now been appended. I can see the length of a list. Length is a universal command. Length of the list, it's 11. Let's look at a couple of more inbuilt functions available over here. I can say list count, extend, index, pop, reverse, sort, several of them. We look into a couple of more as and when we require a list. But for now, I think this would suffice. Now, this was a homogeneous list where all the elements inside a list were of the same data type. But that's not necessary. You can actually have something like a list of an integer number, a decimal number, a string, and another list probably, let's say 1, 2, 3, 4. And if I execute this, I have a new list, which is a data type list, and has 4 elements. The first element is an integer, the second element is a float, third element is a string, and the fourth element is the list itself. Now I can create a list of nested lists in itself. We'll get at the complexities and what all other formats exist, and probably what other operations we can do as and when required. Let's move on to the next data type, which is tuple. Now, the difference between list and tuple is very straightforward. The primary difference is tuples will actually be loaded into the memory once and can never change it. So with list, in this scenario, let's say we want to access list new, and the third index, which is the fourth element. So I'll get the value which is again a list 1, 2, 3, 4, 5. Now what if I wanted to update it? I could say the access that appropriate number, and I'll say, and I'll update it the new value, which is a string value. Now it gets updated, and if I check or print the list, I can see that the list is now updated with the new value. You see this? We have the new updated value over here. But there are scenarios where, let's say, if you assign a value to a list, you would probably want that to remain same throughout the program's execution. Or probably you would have strict rules that these values should not change or they should be immutable. That's when we have a tuple. So let's say we have this list new, which is the new list which is created after modifying this value. These values should be the final ones, and no one should be given the permission to alter these values. That's when we can use the data type tuple. Once a value is stored inside a tuple, we cannot change it. So for example, we create a new tuple, let's say tuple1 is equal to tuple of an existing list. Let's say we create it out of list new. So now this would be a tuple. Now if you come over here, tuple1, the type would be tuple, size would be 4. And the good part of this would be it's immutable. Now we can access the elements of a tuple similar to what we have done for a list. So I'm saying tuple of 1, 1 would be the second element of the list. We can actually access that value. But then if I want to change it, let's say I want to change it to a new value, I would say update it to 100. Now if I try executing this command, you can see that we get an error message saying that tuple object does not support item assignment, which means we cannot change the value during the course of the program execution. So that's the difference between a list and a tuple. We have one more data type which is almost similar to a list, and we call it a set. Now this is similar to the set theory which we have learned during our college days in mathematics. We create a set of objects where duplicacy is an issue. So you cannot have duplicate elements inside a set. So let's say we create a set from a new list. I'll say set1 is equal to set of list underscore new. It's the same process, and you can see that we have a new data type over here. I think we execute this. Let's say we print this. We have the values over here. String 1 and new value. You can definitely change the values of the set elements. The only difference is you cannot add duplicate values. But in case if you add duplicate values, it won't throw you an error, but it will just remove duplicate values. So for example, let's say we have a set called set new, and we're creating a set of a list of 4 elements. Let's say 1, 2, 3, and 4. Now this would be a perfectly valid set. We'll have the values over here. My apologies. We made a small syntax error over here. Yeah. This will be a perfectly valid set. If I execute this set new, we can see that there are 4 values over here. But let's say if we add duplicates over here, we add 4, 4, 4, and 4. So we have 5 instances of the value 4. But if I execute this command or code, it won't actually throw an error. It's just that it will remove the duplicates, and if you check the values in set new, there'll still be just 4 elements. If we add a couple of more, let's say we add something new, 5, 5, 5, that new values will be incorporated over here, and you can see that the values are non-duplicated ones. So we use a set when we are least bothered about uh, having duplicate values. It's just that we just don't care about duplicate, we just need unique values, and you don't want to actually take care of ensuring that every time an element is added into a list, there are no duplicate values. So in that scenario, set would be an idle thing. Now, like uh, indexing in list and tuples, indexing is not supported in the set data type. The last part, or the last data type which we would like to cover in this section, would be a dictionary. So dictionary is a scenario where we want to access values with a key value combination. So let's say we have something called dict1 and we're creating a new dictionary with, for dictionaries, we create dictionary1 is equal to curly braces and then we put in an index a with some value. It could be, let's say, 1 to 3. Then we'll have another value separated by a comma, let's say b, and we have the value some string, let's say the. This is a dictionary of 2 elements. Now, if you look over here, we have the dictionary1 created with type dict, and it has size 2, and it has 2 elements, 123 and the. But the way you access the dictionary would be with the index you have created for that particular value. So if you want to access 123, the index corresponding to 123 is A. That is, it's a key and a value pair combination. So if you have it A as the index, we can actually access the value. We've not A. Oh, sorry. There you go. You can see the value 123 being accessed. You can then access the remaining values. Let's say access with B. You can access the. So you can actually have homogeneous as well as heterogeneous values inside a dictionary. And you can append the values to a dictionary. You can add more values to a dictionary. It's just like the same stuff. So let's say I will say dict1, and I'll say a new value t is equal to 100. And if I execute this, I'll have the values updated with the third key value pair. So whenever you want to access any data type or any data values with a key value pair combination, dictionaries are the ideal ones. This comes in handy specifically when you're handling JSON files. We have specific use cases where dictionaries are extremely useful. We'll have all of this in practice in the upcoming sessions when we get hands-on with data engineering. That's the time when we'll have majority of the codes and majority of the functionalities of these 4 different data types exploited to a different level. But for now, just for the basics, I just wanted to showcase the 4 important data types, basic ones like Boolean, integer, float, and string, and the more advanced ones like list, tuple, set, and dictionary. Next, we'll actually look into something more advanced within Python. That would be NumPy and Pandas. NumPy and Pandas provide us an easy way to handle array operations and data frame operations. We'll get into the details, but let's get back